Welcome to PM Lectures channel. Today we are going to discuss about the topic Cotal Electromagnetic Transmission. This transmission have been developed by Peugeot, a French car maker. So we'll be discussing about Cotal Electromagnetic Transmission. So first, what is Cotal Electromagnetic Transmission means? It will be having electromagnetic devices. You can see in the sketch. This is the layout and other details we'll be seeing one by one. So first we'll be starting from here. That is, you can see electromagnetic devices will be there. That is, these are this and all electromagnets. So instead of having a brake band clutch, we are using electromagnetic devices, and they are having epicyclic gear train. So this one is first planetary gear set, and this one is second planetary gear set, and this one is for reverse. So normally this Cotal electromagnetic gearbox will be having two planetary gear set. So the each planetary gear set will be giving two gear ratios. This one 2 and this one 2. So what will happen? Totally we will be having four gear ratios. So we'll be discussing about first the epicyclic gear train, then we will continue with Cotal electromagnetic transmission. So we know that in epicyclic gear train we'll be having three gears. That is this one. We will be naming it as ring gear, and here we are going to use the word crown. And this one, the center one, normally we'll be using the word sun, but in this French acronym they are using planetary. The center one is planetary, and this one will be using the word planet gears, but here we are going to use the word satellite. So be comfortable with this word. That is, as per French acronym, we are going to follow the notes. That is, the center one will be termed as planetary gear, and the three gears are called as satellites. And this one is ring gear. It can be termed as crown also. So what will happen, this ring gear, that is A, it will be having internal teeth, and you will be having a planetary gear, that is B. You can see it, it will be having external teeth. We'll be using the word sun gear also, but in this lecture we are going to use the word planetary. Okay, and this one, the three gears, that is a C one. This three gears termed as C, we are going to use the word satellite. It also has external teeth. Only A is having internal teeth. And you can see the C will be rotating on the axis D. The D is nothing but axis. It will be rotating on the axis D. And there is another part called carrier. This carrier will be enclosing this all satellites. That is, you can see here in, that is a E. E is called satellite carrier. So this satellite carrier, it is like a plate. It will be enclosing all the center of this satellites, and you can see this satellite carrier plate can be rotating freely on the shaft which is carrying the planetary beam, and also it can rotate freely on the shaft which is coming after A, that is extension of the ring gear. It can rotate freely on that shaft also. So we are having three gears, that is A, then B, then carrier E. So you have to remember, A is the ring gear, B is the planetary gear, and E is planetary carrier. We are not bothering about the satellite for input and output. So among this A, B, and E, one thing will be input and another thing will be output, and one thing will be fixed. So when with this combination, I can have different speed and different ratios, different gear ratios can be obtained. So in this epicyclic gear train concept only, this Cotal electromagnetic transmission is going to work. How to fix or how to make to rotate, that will be electromagnet. That is there are two parts in Cotal electromagnetic transmission. There is one is magnetic part, there is electromagnetic part, and another one is mechanical part. So here you can see, first we will see the Cotal box. That is already I have told you, two trains are there. You can see it in this sketch. This one is first train and this one is second train. The two trains are epicyclic gear trains, and the two will be in series on the same shaft. And this one reverse gear. So here what is the main thing is, reverse gear will be having, that is reverse will be having the same speed of first or second. Normally, in other gearboxes, the reverse gear will be having a definite ratio that will be lower and comparable to first. Here, the reverse gear, there is no separate ratio. When the reverse is engaged, we'll be going in a reverse mode, but the gear ratio, it can be either 1 or 2. That is, it will be taking the forward gear speed during reverse. And we'll be seeing the component, the first component, you can see it here. That is, you will be having this controller. This part is called controller. This controller is a electrical connection. So this controller, we can say controller switch, and it is under steering wheel. So it will be used for getting the different gear ratios. So the gear ratios, how we are going to obtain is, it is electrically controlled and it is placed under steering wheel. And after this controller, on the dashboard we'll be having a gear reversing lever. That is, you can see in the dashboard we'll be having a gear reversing lever. So in this gear reversing lever, so there will be three position in this gear reversing lever, that is will be available on the dashboard. That is forward, neutral and reverse. That is, once you are going to start the vehicle, initially this lever will be in neutral position. The name of the lever is gear reversing lever. So three position: forward, neutral and reverse. So when you want to move forward, you'll be having this F, and neutral N, and reverse R. And neutral, in French, they are using the acronym PM. You can see in the slide. So what is the main advantage of this Cotal electromagnetic transmission? Now in ordinary gearbox we'll be having a handle. Here we don't have any controller handle. It is a lever. It is somewhat easier to switch over the gears. And we will be seeing how many gear ratios are possible. That is, they are having two gear boxes. That is, one is normal and another one is overdrive. So let us discuss about it. Okay, let me write it here. So normal gearbox will be having gear ratio 1, 2, 3, 4. 4 will be direct. In certain cases, instead of 4, they will be using S. S stands for direct. In overdrive, I think you know about it. Compared to input, the output speed will be more. So overdrive also will be having 1, 2, 3, 4, where 3 will be the direct. The same speed of input shaft will be obtained in the third gear. Whereas fourth one is overdrive. That is overdrive, the speed of the output shaft will be more. And what is the main thing that is in this position? No, that is, you are having this position between 1 and 2, between 2 and 3 and 3 and 4, we are having a neutral position. That the appropriate term we are going to use is electric neutral. The lever position between two speeds can be termed as electric neutral. So let us discuss about how to start and operate this car with the Cotal electromagnetic transmission. So first what you have to do, there are two components. One is gear reversing lever and another one is controller. Controller is for gear ratios, where gear reversing lever to go for forward, neutral and reverse. So sorry, when you are going to start, you have to keep this gear reversing lever in neutral position. Then you have to start the engine, and there will be a pedal also, the pedal for disengaging the clutch. You have to press the clutch pedal, so that clutch will be disengaged and reversing lever will be neutral, and you have to start. Once the engine is started, then you have to put the reversing lever into F, that is forward position. Now you have to come to the controller switch. So the controller switch, you have to put it in the first gear. Then after that you can release the clutch pedal, and then the power will be transferred to the road wheel and you can accelerate the engine. And already I told you the switch handle doesn't require much effort. And the main another advantage is you no need to disengage the clutch when you are going to shift the gear upwards as well as downwards. No need of clutch disengagement. You no need to press the clutch pedal or release the clutch pedal. So only at the starting you have to do it. When you are shifting the gear up or down, the clutch disengage is not required. Then now we have discussed about starting. We'll be discussing about stop. So regarding stop, what you have to do is normally you'll be applying the brake, then disengage the clutch. Then after that you have to bring this controller switch in neutral, so that your vehicle will come to rest soon. If it's a prolonged stop, the stopping is more. That is, you can see similar to parking brake. Then you have to go for this reversing lever also. You have to put in neutral mode, so that either the vehicle will not go forward or reverse. So that is the main advantage of gear reversing lever, and we are having this controller switch. Next, we have discussed about overdrive. So overdrive, the main thing what you have to do is, that is the fourth gear will be overdrive, and you should be using this overdrive when you have to travel in the speed above 80 kilometer per hour. So we have seen the introduction of the Cotal box. It simplifies the gear change, and you can see this is the main sketch of this Cotal electromagnetic transmission. There are two parts. There is a casing, two parts. This one is clutch side and this one is transmission side, and we'll be having different parts, electrical parts and mechanical parts. So we'll be seeing the different parts. So carefully go through this construction is very important to understand the Cotal electromagnetic transmission. So first we will be discussing about electrical part. You can see this A is a electromagnet. B also electromagnet. A is a rotating one, where B is fixed one. And similarly C, electromagnet which is rotating, and D is electromagnet which is fixed. Sorry, C is fixed and D is rotating. So you have to remember the electromagnet which are fixed or lying nearer to each other. P and 6 C are electromagnet which is fixed, and A and D are electromagnet which is rotating. And you can see the armature, the center one, this one. G is the armature between A and B, and I is the armature between C and D. So what will happen when the current is going to flow through the electromagnet A? It is rotating. So my armature also will rotate. We will see the connection of the armature with the epicyclic gear train later. So now you please understand, when electromagnet A is rotating, the armature will rotate. And similarly, electromagnet B, current is going to flow through electromagnet B, it is a fixed one. My armature will be rest. So whatever planetary gear which is going to connect it to that armature, that will be at rest. Similarly here, the armature is I. When I'm going to pass the current to the armature C, it is fixed. The armature will not rotate. When I'm going to pass the current to the electromagnet T, the armature will rotate. So why I'm using this? I am applying brake and releasing it by using this electromagnet. So when the current is supplied to the appropriate electromagnet, the armature will be rotating or fixed. And along with the armature, that gears will be connected. That will be seeing in the next slide. So we have discussed about the electrical part. Now we will go to the mechanical part. So first mechanical part, you can see motor shaft. So this one is input to the gearbox. That is, I will be getting the input motor shaft, and this one is output of the gearbox F. And you can see in epicyclic gear train, already I have told you, we'll be having a center one, planetary, then satellite, then I will be having a ring gear. So we are going to discuss about this. And ring gear, we are using the word crown. So you can see on armature I, that is armature I will be connected to crown on armature I train. That is, we are having two trains, first train, second train. So you can see this crown, that is H. Yeah, you can see H. This is the crown. Okay. So you can see my armature is I. Okay. Armature is I. It is connected to crown H. So what happened now? When armature is rotating, my crown will be rotating. When armature is fixed, my crown will be fixed. That is the main thing. Okay. Now we will come to next epicyclic gear train set, that is E. That is, you can see here E. E is the crown on second epicyclic gear train. Okay. So here it is linked with armature I. Okay. So this sorry, this crown is not connected to armature I. You have to remember, only in first planetary gear set that armature is connected to the crown. Okay, in second planetary gear set, the armature is connected to the planetary, that is on the shaft. In next sketch, you will be having a clear idea about this, because the sketch will be simple. Okay, so here that we are having this crown, no, that will be connected on receiver shaft. So what will happen, whenever this crown is rotating, my receiver shaft will be rotating. So that is the main thing you have to remember. Okay. Then we will be discussing about planetary. Planetary on motor shaft, you can see L. You can see it in the sketch. L is here. It is a planetary, the center part. And K is satellite carrier. That is what is a peculiar thing in this Cotal electromagnetic transmission, will be having a double satellite carrier. That will be common to first one and second one. You can see it in the sketch, a simplified sketch here. You can see a double satellite carrier. Okay. So this certain things will be made it clear in the next slide by a simple sketch. So next we are going to discuss about the reverse part. That is, you can see N is the crown of the inverter. Then we are discussing about the fork, and this one is a Q. Q is nothing but lever and fixed gear and other things. You can see in the sketch and you can get the idea. Now we'll be going for working of this rivets. Okay. So what is the main thing is, in this Cotal electromagnetic gear train, first set of epicyclic gear train, this one, and second set of epicyclic gear train. Here two ratios will come. Here two ratios will come. And before that, I'll be having this reverse mechanism. Reverse mechanism. That is, when I am having this lever position, that is, I am having a ball and spring and ball that will be keeping that lever in a position. Either I need forward or reverse. That depends upon this position. So once I'm selecting this reverse, no, the vehicle will be going in reverse, and whatever gear ratio I'm going to get, I'll be getting from first and second epicyclic gear train. So that is the operation of this reverse gear set. It will decide whether the vehicle is go out to go in forward or reverse. So now we'll be discussing about the reverse set. So this one, it is a complicated sketch. In subsequent slide, the important planetary gears will be shown to you. So now we'll be discussing about the reverse part alone. First, we'll be discussing about O. O is nothing but a pinion. Here you can see inverter means reverse. Okay, O is a pinion for the reverse. It will be rotating on the shaft M, and it will be having a satellite. Okay, so satellite means it is a three gears, that is a satellite. That satellite will be called as a inverter satellite, and we will be having a crown for this reverse set. That is, you can see it here, crown of the inverter N. So in this reverse set we are having a pinion O that can be moved lateral direction. And the main thing what you have to understand this Cotal electromagnetic transmission is, there is no lateral movement for any component except reverse. That is, I can able to move this pinion O on left or right. Lateral movement is possible only for this reverse plate, not for other gear set. So I will be having a mechanism to move the pinion inside this crown. That next sketch I will be showing it. And this one is fork P. You can see P stands for fork. So that will be moving that plate left or right. And O is the pinion, and Q is the command finger of the inverter. You can see it here. Q is the command finger of the inverter. Okay. So you will be having a ball and spring. Okay, so when I'm going to operate this reverse lever Q, there will be a fork movement, that is P, and that will be moving that reverse plate. And this reverse lever is connected by a wire from the dashboard. That is, I told you, gear reversing lever that will decide whether forward, reverse, neutral. So we'll be going for a simplified sketch. From here, you'll be having a simplified sketch. It will be easier to understand. So first, we will be discussing about the reverser operation for different lever position. So I'm having a gear reversing lever. I have selected in neutral position. That is this lever. Already I've told you this one, not a controller switch. Controller switch is for gear ratio. This gear reversing lever will be on the dashboard. So you can see now I'm having a gear reversing lever. I have selected the neutral point. So the sketch, it has been written in French. I have converted into English and I am projecting you for you. Here you can see the ball and spring, and here you can see this lever, fork and other thing. And this one is engine side, and this one is a side view. PM stands for neutral. And here what will happen when in neutral position, you can see it, my pinion O, it is not moved towards right. So what happened here, power will be coming from engine, that is a planetary. This will be rotating, and the satellite also will be rotating, but the planetary doesn't turn. That is the main thing you have to remember. So what will happen, that is, I am putting this gear reversing lever in neutral position. Power will not go to the gear shaft itself. That is in the engine side. I am having this motor shaft. At the center, I am having what? Planetary. So in neutral position, the power should not go to the gearbox. So gearbox get the input from this planetary. That is the reverse epicyclic gear set. That planetary only it is going to get the input. Okay. So what happened? My planetary does not turn. That is, you can see it here. Planetary does not turn this portion. From this portion only, I am going to get the input for the epicyclic gear train. So here the other things will be rotating. That is, you will be having the carrier will rotate and the reverse pinion will be rotating, but the planetary doesn't turn. Okay, that satellite carrier rotates freely. It doesn't transfer the motion to the planetary, so it will not turn. Next, we are coming for forward motion. So here you can see I am pushing the lever towards right. When I'm pushing this lever towards right, you can see this pinion O. It is moving towards right. And what will happen here? Now you can see the planetary will rotate. That is, the satellite carrier will be in this position. It will be transferring the motion to the planetary. So whatever power available in the motor shaft, that will be transferred to the planetary. That will be transferred by this satellite carrier that is coming in forward. So here, in order to get forward, I have to move this lever towards right, and it will be retained in that position by this ball and spring. So you can see it here. Here it is not moved inside, where here you can see it is moved inside, and that it will make the planetary to rotate. Here, since there is no contact, the planetary will not rotate. It is a neutral position that is denoted by PM. Next, we are going for reverse operation. Reverse operation will be moving this lever towards left. So what will happen? It will be coming out like this. It will be coming out and it will be touching the fixed crown here. The main thing what you have to remember is the planet uh, gear, no, that will be touching the fixed crown. So here what will happen? The direction of the planetary will be changed. For example, you can see the motor shaft will be rotating in anti-clockwise, means satellite will be rotating in clockwise, since it's internal gearing, and the planetary will take the shape of this satellite. So here you can see the motor shaft is rotating in anti-clockwise, where satellite rotating clockwise, my planetary also rotating in clockwise. So my planetary is opposite to that of motor shaft. So here what is the main thing is satellite will be rotating and planetary also will be rotating. My carrier will be fixed. So you can see that satellite door, that is a carrier, will be immobilized. Since I am moving towards left, it will be fixed on this crown. It will not be allowed to rotate. So what will happen? I will be getting that direction is getting reversed. When carrier is going to fixed, the direction is getting reversed. I am getting what? Reverse. So with this, we have completed this portion. There is a from the reverse how the power is going to the gear train. So the gear reversing lever working is going to end with this set, that is a forward, neutral, reverse. So this will be happening with the with this of lever, fork and other things. So the simple what we can summarize is neutral point, nothing will be done. The lever will be in original position and planetary doesn't turn. Then forward point, the lever will be moving towards right. This carrier will be moving towards here and it will be imparting motion to the planetary. So planetary will be rotating in the same direction of motor shaft. And reverse, I will be moving towards left. So here it will be fixed. The carrier will be fixed. So the direction is getting reversed. My planetary will be rotating in opposite direction. So with this, the reverse is over. Now we are going to come to the epicyclic gear train, that is 1 and 2. Here you can see the sketch will be more simplified to you. Here you can see these two are electromagnet, these two are electromagnet. And the center one you can see armature G and armature I. Now we will understand the connection. Now you can see armature, sorry, this one is armature G and this one is I have written 1 and 2 gear train. Okay, so you can see it here. First train, second train, and this one is armature G and this one is armature I. So first we will be understanding where the armature is connected. So you can see armature G, it is connected to where? It is connected to the crown H. So this you have to understand. You can see in the right hand side. This armature is connected to crown H. This means what? Whatever motion the armature is going to have, that crown also is going to have that motion. Come to the second train, armature I, it's not connected to the crown, it is connected to the planetary. You can see it here, the central gear in the second epicyclic gear train. Where in the second epicyclic gear train, the crown is connected to the receiver shaft. Okay, so this one is a motor shaft, this one is a receiver shaft, and second epicyclic gear train planetary, first epicyclic gear train planetary L. And here we are having this crown that is connected to armature G, and armature I is connected to planetary J. It's not connected to crown, so the connection is somewhat reversed. So you have to understand that. And you can see this shaded portion. This is called double satellite carrier. This one, the hatched portion is a double satellite carrier, and you have to remember always this double satellite carrier will be rotating. Now we will be coming to the electromagnet part. So what will happen? A, electromobile means it is rotating, and this one is fixed. Let me write B is equal to 0, C is equal to 0 means it is fixed, and D will be rotating. So now listen, that is I am having a armature here. When I am going to pass the current through electromagnet A, my armature will be rotating. My armature is connected to what? Crown. So my crown will be rotating in the first epicyclic gear train. Whereas when I'm going to pass current to B, it is a fixed one. What will happen? My armature will not rotate. Since the armature is connected to the crown, crown also will not be rotating. That's all. That is the logic. Come to the second epicyclic gear train. Here the armature, we are having two electromagnet, C and D. First we will go for C. C is fixed. So my armature will be not rotating. But here the armature is connected to the planetary. So the central gear of the second epicyclic gear train will not rotate. And when I'm going to pass current to D, what will happen? The armature will rotate as that of D. So what will happen? The planetary also will be rotating as that of D. Direct drive will be obtained because D, electromagnet D is connected to the receiver shaft. Since the armature is getting the current from electromagnet D, which is rotating, the same rotation will be transferred to planetary. So it is like a locked. It will be all gears are locked and you will be getting a direct train. And you have to remember in the receiver shaft, we are getting the power from the electromagnet D. So that is the main thing you have to remember. And another important thing is you are having this electromagnet and armature. The air gap between this armature and electromagnet is about 0.25 mm. So whenever I'm going to pass current through the electromagnet, I am generating a line of force. This line of force will be attracting the armature to the corresponding electromagnet, either A or B. If it is attracting to A, it will be rotating. If it is attracted to B, it will be fixed. So depending upon my current connection only, I am allowing this armature to rotate or to be stationary, and this armature is connected to the mechanical part. So indirectly I am controlling this epicyclic gear train, the corresponding gears to rotate or to be stationary by armature as well as by electromagnet. So what will happen is, this electromagnet will be powered in a pair differently. That is, once I can go for A and C. That is, A electromagnet will be rotating, whereas electromagnet C, what will happen, it's fixed. So armature, this armature will be rotating, this armature will be fixed. So depending upon that, I will be getting what different ratios. One in here one gear will be fixed, where here one gear will be rotating. So I will be getting different gear ratios. So now you can see the electrical connections. So this one is very easier to you. That is, you can see the electrical connection. It is a fixing clamps, and these are the wires. You can see the colors of the wire: purple, white, red, brown. There will be a 5 connections. Each wire will be going to you. Here you can see electro A rotating one, and electro B fixed one, and electro C is a fixed one, and electro D rotating, and the center one will be the power source. And the colors, what will be the colors, it has been shown. And this one is the steering wheel. You can see the controller switch, and you can see this one. Once the sketch is getting simplified, you'll be able to understand well. So you can see the current supplying wire YA, current going to the electromagnet A, B, C and D. So here we will compare this overdrive box and normal box. So overdrive, I'll be getting the first gear. Normal also, I'll be getting the first. Second. When third means, I'll be getting a different gear ratio in normal, whereas in overdrive I'll be getting the direct. That is, the output speed will be same as that of input speed. And the fourth one will be the overdrive. Output speed will be greater than that of input speed. And here, whatever the overdrive I'm getting in the third speed, that will be obtained in normal one. And neutral, in French we are using the word PM. You can see the position here. PM stands for neutral. So here another exploded view, that is, you can see electromagnet A, B, C, D, and between A and B I'm having armature G, and between C and D I'm having armature I. This one is motor shaft, and this one is receiver shaft, and this one contribute to the first train, and this one is second train. So you can see the electromagnet turning will be A and D. A will be rotating. Fixed is B and C, and armature G and I. Now the sketch has been broken down. You can understand this electromagnetic part well from this sketch. And this one again, that cable connections and other thing, arrangement of connections in the controller. You can see the wire which is going to the electromagnets A, B and C, D. Now this is the main thing you have to see. This one is overdrive second train. So in this sketch you have to remember, overdrive gearbox second train we are going to see, not first one. That is, this train we are going to see second one. So this exported view will be able to uh, will be making you very clear. See, C is electromagnet, it is fixed. I am passing the current through the electromagnet. So the armature, this one, will be fixed. And in the second epicyclic gear train, this armature is connected to the planetary. So the central gear, that is planetary, will be at rest. And here we are having electromagnet D. And you can see the D is coupled to the receiver shaft. So the receiver shaft get the power from the electromagnet D, as well as the D is integrated with the crown E. That is, you can see E is the crown on receiver shaft on rotating electrode D, where J is planetary on armature second train, and K is nothing but satellite carrier. You can see here and here. That is, it will be carrying the satellite in the first epicyclic gear train, and also it will be getting the uh, taking care of the satellites in the second gear train also. So this satellite carrier is going to give a connection between the first train and second train. So this is the main thing we are going to discuss about this, how we are getting the different gear ratios, normal and overdrive. So you can see in normal, first train GR stands for gear reduction, second train also gear reduction, and electro excited, the electromagnets B and C current will pass. I will be getting the current gear ratio about 0.33. Similarly, DD stands for direct, and I will be getting the gear ratio of 0.46. So in fourth gear, I am getting what? Direct. That is 1. We'll be discussing about this overdrive. So overdrive, what will happen? There will be gear multiplication will take place. GR stands for gear reduction and GM stands for gear multiplication, and DD is direct. So what will happen? We will discuss about the first train. That is, I am using this electro B and D. Okay. So you please remember electro B and D. We will go to the sketch. Okay. So see here, this one is A, B, C and D. So I am passing the current to B and I am passing the current D. Okay. So B is fixed. So B is fixed means what will happen here? Here the crown will not rotate. So here the armature, this one is G, it is given here, and this one armature I. So I am getting the power from the motor shaft. I am passing the current to B. What will happen? Armature G will not rotate, and armature is connected to that electro crown H. So this one is H. So what will happen? H is fixed. So there will be a gear reduction. So you have to understand, in first train I will be getting the gear reduction. That is, this planetary will get the speed of the motor, and the satellite will be rotating, and that motion will be transferred to the second train by satellite carrier, but the crown is fixed, so there will be a gear reduction. So what will happen? The speed here, the direction will get reversed for satellite will be rotating in opposite direction to that of planetary on the first train. Then satellite carrier will transfer to the motion to the second train. So what will happen here? D is current pass through the electromagnet T. So it is rotating. The armature I will be rotating. So I is connected to planetary of second gear. So what will happen? This planetary will be rotating since D is rotating. So D is rotating, and this electrode D is carrying the crown. Here I am having the crown E. This portion is E, crown. Okay. So E and planetary both are rotating at the same speed. So it is, the gear is locked. So I am getting what? Direct speed. So in this gear train, the first reduction what I am getting, no, the same thing is transferred to the receiver shaft. So like this you have to correlate the other thing also. So see, when I am going for B, it produce gear reduction in first train, and D giving the direct drive in second gear. So you can see, for overdrive, for first gear itself I am getting 0.46, whereas here normal I am getting in the second gear only. Okay. Similarly, I'm going to excite B and C. Whenever I'm going for B, the same thing, gear reduction will be same, the same process. Now we will see the gear multiplication, how it going to happen when I'm going to have this C. Okay, so I can explain from this sketch. So what happens here? C, I am passing the current to C. It is fixed. So my armature is connected to C. There is armature will be driven by C. Armature will be at rest. So what happen? Planetary. This planetary will be at rest. The satellites in the second gear, the satellites is attached to the satellite carrier, and also it rotate on the fixed planetary. It rotates on fixed planetary, that is J, because the center one is fixed, and we are having this crown E. So the center one is fixed, satellites are rotating, and the satellite carrier is getting a revolt. So it will be driving the crown wheel E at a speed greater than that of the receiver end. That is the main thing you have to understand. By operating C, it is fixing the planetary. So the only planetary is at rest where satellite is getting rotated, and satellite carrier also rotating, so it will transfer that speed to that crown. So the crown will be rotating at higher speed. So here multiplication is taking place. So you can see it whenever I am having C, there will be gear multiplication, output will be rotating at a greater speed. Similarly A and D, it is very simple. That is in this epicyclic gear train, when I'm going for A and D, what happened? A is what? It is rotating. So the armature will be driving this crown as well as the planetary, both are same speed, direct speed. Whereas here D is rotating. So D is connected to the planetary, and this electro is integral part of the crown. So both will be at same speed. So in two gear trains, I'm getting what? The direct speed, so I'm getting 1. Now for C, what I will go, no, I will be taking this A, direct drive, because no reduction in first train, and I will be going for C. See what happens when I'm fixing, when I'm passing current through electromagnet C, this gear multiplication take place. So I will go for a combination A and C. So I'll be getting what? The overdrive, that is the speed of the output will be greater than that of input. So with this, we have discussed the working of Cotal electromagnetic transmission. There is, you can see the history of the Cotal and other things we have discussed. So we can see the cars where Cotal gearboxes are used: Arcus, Bugatti, and Peugeot, Citroen. So these are the cars where Cotal gearbox have been used. So with this, we are ending this lecture. And any suggestions and any errors, you can intimate me through email. And we'll be discussing the next topic in the upcoming lecture. And if you feel this lecture is interesting and useful to you, subscribe to my channel. Thank you.